Thank you so much. Well, thank you, first of all, for being here, especially if you didn't expect to be coming to this talk. But I very much appreciate you being here. Um, cool. So, actually, I'd love to see by a show of hands in this room if you consider yourself more of beginner Go or sort of mid-level experience or advanced. So let's start with beginner. Awesome. Oh, welcome. Cool. And what about kind of mid-level? Awesome. And then more advanced? Cool. Yeah, so quite a good mix, which is nice to see. It's really cool to see that there are folks that are just coming into Go experience. I think one of the things I love the most about the Go community is how welcoming it is. So that being said, this talk is aimed for sort of all levels, but it is meant to take things from very small to then large, and that kind of fits in with the scaling definition there. And the reason for that is I wanted to make it as accessible as possible, and so it's hopefully designed with kind of a beginner-friendly view. And if you are more senior, then hopefully you can get some tips and tricks from what I've learned from using Goroutines in terms of deployments and scaling. So I will tell you a bit about myself. This is me in the early 90s. This is not the beginning of my programming career, but I owe a lot of kind of what I do now to my dad. He bought this computer with a bank loan because he didn't really know anything about computers, but he knew that they were going to be a big thing. And he thought, well, my child should probably know about this. And then when I was a teenager, my dad was kind of like the computer guy in town. He fixed everyone's laptops when they had viruses and all of that. So then when I needed help, he was like, no, go Google it. Just figure it out yourself. And I think that's informed a lot of how I have turned into a programmer. So despite that, I didn't go to school for software engineering. I took a gap year that turned into 7 years, and I worked in HR for a restaurant group. And then I did a career switch. So in 2018, I went to a coding boot camp. And I got very lucky. When I came out of that, I got a job as a junior dev working in Go. And I had a great tech lead who really wanted to just like mentor someone and teach them. And so the reason I bring this up is because my talk is kind of influenced by that. I don't come from a Java background, so the way I'm going to explain Goroutines and concurrency is very much in line with that. So now I work for a company called Dapper Labs. And Dapper, if you're not familiar, is a blockchain NFT company. We created NBA Top Shot along with like CryptoKitties and a couple other projects. So I've been there for 4 years, and I've seen it through the like NFT bubble in 2021. We got very busy, a little less so now, but that's okay. Yeah, in my spare time, I like hiking and skiing, and I like to knit. I've been knitting at the conference. I'm a fidgety person, so that's a hot tip. It helps me focus. And I do pottery. So we will start with a step-by-step example, which is set out how you might start a project. Starting with a small example, building off of it. And I'm sure, as a lot of people know, that the process of writing software is kind of done that way. Usually concurrency is not brought in until you need to use it. And so then we will look at how to scale for speed with Goroutines, and also look at scaling for load and how to use deployments. I'll talk a little bit about a case study from a project that I worked on. And then I have a link to a tutorial that I've also created for this talk, so if you're interested, or if you have people you work with that want to understand concurrency and Goroutines better, feel free to share that around. So this is what happens when you let backend engineers make their own slides. This is coffee. We're going to talk about coffee because I find it really helpful to work off of analogies. And I think we'll imagine that collectively in this room we've decided to quit tech and open a coffee shop because every programmer I know just wants to leave the industry and open like a potato farm or something. Those are giggles of recognition. Cool, so for the purpose of this, we'll imagine that we're like the founders, the investors. And our main goal and the kind of big question today is, how can we serve as many cups of coffee to as many people as possible as quickly as we possibly can? The way that we're going to do that, like I said, is focusing on both speed and load. So how quickly can we get customers in and out the door? And then how much can we scale up the number of customers while still maintaining good speed? So we'll get together, pool some resources, and get set up. And we'll be just a coffee shop that does one coffee, and it'll be a cappuccino because we're in Italy. And so for every customer that comes in and orders a cappuccino, we're going to do 3 things. We will take their payment, steam milk, and make espresso. And imagine that those are the only 3 things that go into making a coffee. So there's obviously additional actions, like you got to put the milk in the coffee, but we'll ignore that for now. So we've got our coffee shop all set up, and we're going to hire our first employee. Does anyone want to volunteer? You don't have to do anything. I'm going to pick on someone. Daniel, you tiny go guy. Can I use your name? Have you ever worked in a coffee shop? No?
Yes, as a bartender.
As a bartender, okay, there you go. You've worked in hospitality. Would you like to work in this coffee shop?
Yeah.
I'm sorry, you sat in the front row. You did this to yourself. Okay, so we're gonna write this in code. So we've hired Daniel. He's gonna be our first coffee shop employee. So let's imagine this in code, right? We have 3 functions for each of these actions, and we're going to run them one at a time inside our main function. There's also this log that tells us how much time this code takes to produce based on the start time as well, and that'll print out. In each function, there's a sleep, so that creates a delay, which might mimic something like when you write to a database or some other action. And that's just going to make it clearer how long the function takes to run. So right now, this is just a code file in my editor, and I can run the code with go run main.go command. So right now, how long do you think this will take? What do you think the printout will be? You can shout it out. 6 and something. Very specific, I like it, and correct. Yeah, so 6 seconds, right? Because basically we've got Daniel here is going and making espresso, then steaming the milk, then, taking the payment first, and then serving it to the customer, doing it all by yourself. So now I'll just go into a little bit more setup because we want to have this capable of serving more than one customer. And I want to make this a little bit more flexible, but also set this up as a server because we're effectively building out a web service, and this will help us later when we package it up to deploy. Cool. So I've adjusted the code slightly here. The main function is using the HTTP package to set up a route that parses an optional parameter for the number of customers, and then it loops through the number to make a coffee for each person. So we're still testing the time it takes to run, and at the bottom we'll print out the number of customers and how long it took to serve them. I've also just bundled the 3 actions into a helper function called make coffee, which will run each of these 3 actions. So now when the program runs, we can make a curl command to localhost. And if we try to serve 3 customers, what do you think it will print out? 18 seconds, yeah, because this is all happening one at a time. So we're trying to serve 3 customers. We got 3 actions. We're doing them in one go. This is a lot of work for Daniel. And this is our first problem to solve, right? So this is speed. How can we speed this action up? Because right now for every customer, it takes an additional 6 seconds, right? And this is where we can use Goroutines to help optimize for our first problem. Speed, you probably know, is a pretty important part of what we do. It's especially important when you have an API that serves a web app that serves customers, and very important when you have customers that you want to take money from. So first step with using Goroutines is don't. Obviously, we're at this scenario now where we've kind of realized the need for them. And I always just caution as well, when you're thinking about introducing Goroutines and concurrency into your code, remember that when you're adding asynchronous actions, you are adding complexity. So it makes the code just a little bit harder to read. It makes it a little bit harder to test. So just make sure that you actually do need to do it. And an example of where you might not is we have some very low traffic endpoints that have a to-do from 3 years ago that says optimize this, because technically we could make it faster. But I mean, it works, and it just hasn't really been worth the, I guess, over-engineering. So just make sure it's something you want to do, right? I feel like, yeah, I guess when it comes to Goroutines, I think you can actually go a long time in your career in backend development without ever writing one that goes into production, because it's not maybe the most obvious thing, especially if you're new to the language. But obviously, in our case here, we do want to use them, right? We're investors, we're we need to make this as fast as possible. So we're losing customers because it takes too long. So let's introduce concurrency. And here, we have 3 actions that can be done at the same time, right? They don't depend on each other. Daniel's our star employee, doing a great job, but we realized that you could be more efficient if you had more help, right? Thank you for going along with this. And Go makes this so easy for us, right? We just add Go at the beginning. Go run Goroutines. So Goroutines are unique to Go. They can be thought of as lightweight threads. They're not exactly threads, but a thread being, at the very basic explanation, a sequence of instructions inside a program that can be executed independently of other code. And what makes them powerful is that they can be used to run functions at the same time or concurrently. So here we go. We've used a Goroutine for our make coffee function. How long do you think it'll take now? 6 seconds? So that's weird, right? Yeah, so I'm hearing a couple people here have picked up on that. So we've got the printout at the top and then all the logs. We have milliseconds. And so we go to Daniel and we're like, hey, what's going on? Because we're starting to get some bad Google reviews. And Daniel's like, no, it's great, it's great. We are serving coffee. We've got people in and out the door in seconds. It's cool. And we're like, did you train the new employees? Did you train them? And we find out that maybe they need a little more training. So, because people are kind of just running around chaotically, they're steaming milk and leaving it on the counter, and people aren't getting their coffee. And this is because basically the Go says, go do your Go routine, throws it out into the wild, and then just goes, it's done. We'll just finish the function. So here you can use a wait group, right? And wait groups will make sure that all of our Go routines have finished before ending the program. And that way we know for sure that everyone gets their coffee. So what we do here is use the sync package, which allows us to create a wait group variable. And then the built-in add function adds a counter for each Go routine we spin out. And then we pass the wait group into the function we're using as a Go routine and calls waitgroup.done which decrements that count. So the wait group wait at the end tells us to wait until that counter has reached 0 before we continue. So basically, we're taking advantage of Goroutines, but we're also making sure everything is done before we finish. We gave Daniel a little too much freedom, so now we're just kind of reining that in a little bit, and making sure that everything's done before we give people their coffee. So now, how long do you think it'll take? 6. Yeah, 6 seconds, right? 6 seconds to serve coffee to 3 customers. So this is a success. Do you think we can make it faster? Yeah. Thank you for the enthusiastic yeah from over here. I appreciate it. Okay, yeah, so we can. This is where we can look inside the initial function, which is running in a Goroutine, see if there's anything else we can run at the same time. And we do have that in our 3 actions, right? Because those can be run independently of each other. So I've made these into Goroutines and set up a new wait group inside the make coffee function, which waits for all 3 of these to finish before it ends. And now we're down to 2 seconds. Yeah, great. Okay, so yeah, we've hired some more employees. We've got some more machines, like more coffee machines, and we can take payment, make coffee, and steam milk at the same time. Okay, so now we want more customers, right? We want to scale this up. We're serving lots of people, but there's like only so many people we can get in the door at a given time. So we start hiring more people. And this is where we get to the next hurdle, which is load, right? So we've optimized pretty well for speed, but now we want to serve more people. And how do we scale this operation up to be able to handle more load of more incoming people? We are also getting interest from investors because we've run this like pretty successful little coffee shop business. And maybe they want to like build up some franchises with our business. So we want to be able to package up the success that we have here, so that maybe we could open more stores. So I'm not going to go super in depth on the like Docker and Kubernetes side, but I've done the like bare minimum of what you need to get something kind of like physically working. If you were at Bill Kennedy's workshop on Sunday, I'm very jet lagged. I came from Vancouver, so I have no concept of days. But he talked about deploying first, so getting something to deploy as quickly as possible, and that's very much how I like to write code. So basically, I've added a Docker file with instructions to build out an image of our little program. And first, we import the base image, Go 1.18.4, a little outdated now. The work directory adds a directory inside an image, and then the copy go.mod and go.sum. Run go.mod download sets up our modules, although we're not really using those in this example. It's an empty file. Then we copy our source code in, and so into the image with the copy command and compile it using the run command. We add the command so Docker knows what command to use when the image is used to start a container. Cool. So I also set up a little makefile, and I have a link to like all of these scenarios in code, if that is of interest later. This is just for convenience. This will set up the Docker containers and tear them down. And it also publishes the port, so we can hit the endpoint. And so at a very like high level, what we have is we can make an image, which is sort of like a template of our code that we've written, and we can make a container, which is the thing that our code is running inside of. And the container is, I think of it as like the container uses the image as a template, right? So now we can spin up a Docker container and hit the exposed endpoint. This is still just running one instance. So to scale it up, we need to get it inside Kubernetes. And then we can start to look at what levers we can pull for scaling. So this is just my Kubernetes deployment YAML. This will create a deployment in our cluster, our Kubernetes cluster, with one pod. Again, this is my high-level visual of what goes on in my brain when I try to visualize this stuff. We have one deployment running and one pod. And then that's our little container of our coffee shop. So I have to port forward, which is in the makefile. And right now, but later we'll add another layer that does that for us. So now we get to the scaling options. And we have two options that are immediately available to be able to allow our program to handle more traffic. The first way is to scale vertically, which means adding more power or more resources to the pod. So this is where we've got our cafe all set up, running smoothly, and we're ready for those big franchise dreams. But first, the investors want to see us do bigger numbers, right? So we buy some espresso machines and invest in some more cash machines, hire more cashiers, start bulk buying milk. And in this case, we're going to look at the resources we have available to our pod. So we have CPU and memory. And these are resources that are available to scale up and down on your deployment. The pod runs inside a node, and the node will have a certain amount of available resource. So the pods can use more than the request if there is more available, but can't exceed the limit. And for this example, we're going to set them at a very low amount and just see what we can do with that. So we'll set 1 milli-CPU, and this is 10 megabytes, which apparently stands for mega binary byte. And so what happens if we spin this up and try to hit it with more customers, so more than those 3 that we started with? So you can see with 3, we're fine. We're still at 2 seconds. With 30, all good. 300 starts to get a little longer. And then 3000 gets killed or out of memory killed because we don't have enough memory allocated for it. So pods will die if they're using more than their allocated memory. And we are using up a lot of memory the more Goroutines we add, so the more customers we have. You can see there's also a restart because the pod boots itself up every time it dies. But if we try again, it'll continue doing that if we keep hitting it with that number, like over 3000. So this is kind of like, we've given more cash machines to the cafe, but the employees are just getting burnt out because they're like constantly working. Okay, so we can crank up our resources. It's just like add some numbers and see what happens. So let's do 4 CPU, bump the memory up. And now look at what we get. So now we can do a lot more, got 30,000. And then we get to like 3 million before we get out of memory killed again, which I've sort of come from a programming philosophy of do something till it explodes and then see what happens and dial it back. So you might think like, well, just keep bumping it up. Why not? Just add more CPU, add more memory. But obviously, if it was that simple, we wouldn't be here. So nodes have limits, right? Kubernetes isn't just going to like let you use unlimited CPU and memory. It's also expensive. Technically, if you like had a server room, I guess you could go and add more resources, but a lot of us are probably using cloud services, and your DevOps team is probably going to have like a conversation about finances if you just try to use a lot of CPU and memory. So if we think we've kind of exhausted our options or found the right like CPU mem thresholds, we can look at horizontal scaling. we want to open more cafes. So we have our blueprint created. We have this like template and we want to open more. And horizontal scaling is what it looks like, right? It's adding more pods to the cluster in this scenario. More pods means more pods to accept traffic and more resources to deal with that traffic. The nice thing about scaling up pods too is that we can also equalize the resources. So if we have one pod with really high CPU and mem, we're paying for that. But if we have one pod with lower resources and we only scale up during busy times, like if our traffic is dependent on users hitting that API, then we're not like paying for resources that we're not using. And that's where you can start getting into like auto scaling with Kubernetes. And that just means the amount of pods is managed for you, goes up and down with demand. Cool. So we adjust the replicas in our deployment file to spin up more of the same container to be able to handle more traffic. And in this case, I'm going to set the replicas to 2. So we will have 2 pods that can accept traffic instead of just 1. We're also going to add an ingress layer. And this will be able to control the flow of incoming traffic. So before we used port forwarding to use the port that we hit locally. And we can't control which pod the traffic goes to. So if we only scale up the pods, only one of them will get the traffic and the others will just sit there empty. So we need an extra layer which sort of manages the traffic and distributes it across the pods. That comes in the form of this other YAML file. So we define this as an ingress, and we also need to make sure there's an ingress controller running and ready to accept traffic. Cool, so now we have 2 pods up and running. We've opened our second cafe, and when I hit the endpoint over and over again, I can see that the traffic is going to both. So this means we can really scale up the amount of customers that we can serve. So now we have 2 pods that are quite happy to serve 30,000 customers in under 3 seconds. So the more pods we have, the more Goroutines we can handle at one time since they are running independently. And we know like our threshold, and we keep the resources within our limits, and then we have traffic directed across the pods to spread the load. So now we can do this exponentially. And this is where we can like open more and more coffee shops. And we're taking this like nicely packaged formula we have for successful business, and we're copy pasting it across the country. So yeah, we've been very successful. Daniel, you've done a great job. Thank you. We're gonna make you CEO now. Everyone give a little hands for Daniel. Thank you. So, okay, so that's our successful business. Couple just things to watch out for when it comes to Goroutines. First of all, just think about like, do you need this? Do you need concurrency in your program? Wait groups, right? That's important. You probably want to know when your Goroutines have finished, even if it's just for metrics, but also you don't really want those things like, if you don't have a wait group, you don't know if something just died and didn't finish. Also, resources, they have limits. You can't just crank them up. You have to figure out what that threshold would look like. And then the other thing is, and this doesn't show in those examples, but what happens if we just don't cap, so we don't cap the Goroutines, right? We don't have anything that says like, you can't have more than this many going at one time, apart from the pods will die. And that's where you can use, so the worker pools will let you control like how many Goroutines you have going at one time. So especially, yeah, if it's dependent on something like user traffic, which is not determined by us, you want to keep an eye on that. And then the next thing you could do with this is you could start actually splitting up deployments that you use for each Goroutine or action. So you can make it so that each separate deployment is responsible for a different action or a different like Goroutine process and runs them separately. And so this is something we did in the project that I worked on. And this means that you can scale up in a really granular way. So if you think like maybe take payment and steam milk take about the same amount of resource, same amount of time, but make espresso is like quite resource intensive, you could have more pods for that. And this works when you have things that work independently of each other. I don't talk so much about like state management and this or something where like you have to have things that depend on each other. But for this example, it would work. So you could get something like this, where you have a main deployment, and they're all based on the same image and same container. We use an environment variable, and it kind of occurred to me when I was writing this, it's like a little bit of a hack for a microservice that isn't a microservice. And then, yeah, we use an environment variable. So then we say, like, these two pods are responsible for the taking payment Goroutines. These two are responsible for steam milk, and these four are responsible for making espresso. And then you can scale those up and down as you need. I'm going to talk through this next bit fairly quickly. This is sort of the case study. Just talk about it really high level. It's very similar to what we just talked about, but in an example of software I actually worked on. So we have this thing called packs. We sell them to users. They have moments inside of them. Users buy packs, and then they open them, and they get the moments. And this interacts with a blockchain. So each of these actions happens on the blockchain, and because of that, there is a lot of asynchronous stuff going on, and it takes longer. It communicates by sending transactions. So in our example, our kind of things that we can do independently are these things. Minting would be like when we create the packs on the blockchain, and then we'd have to check incoming events, and we also send transactions. So we started that out by using no concurrency. We ran each of these things one at a time. We have a ticker. We basically created like kind of pollers for each of these, and ran these as Goroutines. It works, but it's really slow. And so at one point, like minting packs took a day, and opening them was really slow. It took like 5-10 minutes, which obviously is not great for customers. So then we broke these out into their own Goroutines. And oh yeah, I said Goroutines before, but those were just functions. This is when we're kind of introducing the polar stuff. And this makes it a lot faster. But then we also have these transactions that we can run at the same time, because these are one of the bulkier actions. These have the most, like, if you think for minting, there's like one action, but for opening, minting, transferring, those are all transactions you need to send through. So then we run those transactions within Goroutines, and this is like when we made each of those actions within make coffee a Goroutine in itself. Another code snippet. I won't talk too much about this. But this allowed us to like speed up quite significantly. And then this is sort of a visual of how the deployments set out. So we had each of those kind of processes directed to different deployments. And that meant that when we had periods of really high traffic, we could just like bump up the send transactions. We also had a lot of challenges with the auto scaling because we had very spiky traffic. We've managed that a lot with like queues and things, but this was also something that we did. Cool. And then I won't really talk about keys, but this was like another area where we scaled. So the transactions require keys, and we scaled with basically, we store the indexes for each of the keys, right? And then in each of those deployments, there's like, a deployment is responsible for a specific set of keys, and then the number of Goroutines spun out is proportional to those keys. And so that's actually how we managed keeping like the Goroutine usage down, but we probably would want to introduce like worker pools to control that. So that brings us to the end, and just a brief recap. We scaled by using Goroutines. We scaled horizontally and vertically. And we also split out our deployments into, well, based on how many Goroutines they're responsible for spinning out. So in our case, with this example, we managed to get the minting speed down to an hour from a day, and like the pack opening takes like 30 seconds now. There's still some delay because it is blockchain related. But again, just like making coffee, we can tailor those resources. So start with no concurrency, and then look at how you can use the Goroutines and the scaling. And that brings us to the end. So there's a QR code with my code, examples and slides, and also a tutorial, if that's interesting to you. And yeah, thank you so much. And yeah, thanks again for coming.
Thank you, Sadie. All right, let's quickly move to the question part. Do you have any question for Sadie? Yeah, I'm coming.
So one thing that's a bit tricky with routines is if you error handling. Okay, great. So I'm just speaking louder. So what happens if an error happens? So for example, when the milk just drops on the floor, and so now you have the espresso and you have taken money, but how do you do then if like one of the steps fails?
Yeah, great question. Yeah, so like error handling with one of those steps, right? And so that's where you probably need some form of state management to see, like, okay, I've sent this off to make a coffee. In our case with like packs, we store everything in the database. So we mark when we've sent off a transaction, and if we don't get that back, we have a timeout, and then we mark that as unsuccessful. In the coffee example, if the pods are dying, you probably want to have, whether it's a job or something that's checking, right, that it's been successful. There's like a couple ways I can think of, like how we've done that or how you can make sure that you're accounting for the error handling. But yeah, you definitely want to make sure that you're not just like dropping things on the floor. And I would generally say that the state management is how you would do that. So.
Do we have any other question? No? Okay, I think we're good. Let me check the time. All right, we still have 15 minutes before the coffee break, so I don't know, yeah. Oh, let me just say something in the meantime. So in case you have anything in your wardrobe down there, it's gonna close at 7 p.m. So in order to avoid long queues, please try not to go there all at 7. So if somebody wants already to collect their stuff there during the coffee break, that might be great. Yeah. Anything else to add, Sadie?
Thanks so much. Thanks, yeah, thanks for, go have some coffee.